Hello and welcome, here from the MVTec headquarters in beautiful Munich. The wait is over, HALCON 2205 is around the corner. Therefore, we have invited you to our webinar to talk about amazing new features and improvements of our latest version. But in case you're wondering who's actually talking to you here, I'm now happy to introduce you the speakers of today. With me is Bohnacker, Technical Product Manager HALCON. Also, Peter König, he's one of our application engineers here at MVTec. And the smiling guy on the right side of the slide is me, Markus Setzer, and I am part of MVTec's marketing team. But before we start, some general information. Like always, we are going to have a little Q&A session after the presentation. Please feel free to enter your question in the GoToWebinar tool. Also, this webinar will be recorded and sent to you shortly after the event in a mailing. In this email, you will also find a link to the survey and the new feature slides. Okay, that's it for now from me. Please now, Mario and Peter, tell us everything about HALCON 2205, and we see each other later for the Q&A session. See you then.
Hello and welcome to the HALCON 2205 release webinar, and we are glad to be able to show you the new features of this brand new HALCON release. With this HALCON release we have the major feature Global Context Anomaly Detection, a new deep learning technology which brings the anomaly detection to a new level. We have training for our well-proven Deep OCR technology included now. We enhanced the ECC200 print quality inspection, and we implemented various improvements and speedups which will follow at the end of the webinar. Before we digging deeper into these features, we have one announcement to make, and I know that some of our customers will not be very happy to hear, but MVTec plans to discontinue HALCON for Mac OS at the end of the year. So basically, as you can see on the slide, HALCON 2205 and HALCON 2111 Steady and Progress will support Mac OS, but HALCON Steady 2211 and Progress 2211 will most surely be the last versions which will support HALCON on Mac OS. 2305 most probably will not support HALCON Mac OS anymore. This is one bad news at the beginning, and let's move on with the good news. And this is Global Context Anomaly Detection. Global Context Anomaly Detection is kind of a next step of our already implemented anomaly detection. As the name says, it detects unknown anomaly, but in a more global context, and we will shortly describe in a few seconds what global context really means. It can be used for completeness checks and the detection of defects in an image. So it's basically used for quality inspection tasks. And yeah, we have quite fast development times for you, as like the regular anomaly detection. This method only needs good images for labeling. So let's start with a small example. We have inspection of bottles, and we want to detect if the label is correct and if the input of the bottle is correct. So we train with only good images, like you see on the left, the apple with apple juice in kind of yellow, and the cherry bottle with cherry juice in kind of a red background. So we have anomalies, which we call structural anomalies, which are basically defects on the label, or there's unknown objects in the bottle, or there might be scratches on the bottle. So this is kind of a structural anomaly. New are our logical anomalies, which can be detected with this Global Context Anomaly Detection. And typical errors in our example are, for example, empty or wrong content. So as you see, the logo of the cherry is on a bottle which is filled with apple juice, vice versa. or the label positioning is different, the label is too low or the label is tilted. All these are questions, all these are defects which the new Global Context Anomaly Detection can detect. So let's quickly have a look at the differences between the current anomaly detection and the Global Context Anomaly Detection. In our example, we have several defects at the left, two with the defects on the labels, which were recognized by the anomaly detection. But for example, the label which is shifted to the bottom of the bottle would be detected as okay by the current anomaly detection, as the label is correct, the bottle is correct, and the context between bottle and the position of the label is not learned by the algorithm. And as we see on the right, with the Global Context Anomaly Detection, this context can be learned by the algorithm and it will detect the bottle as an OK. Another example is the example where we change the content of the bottle. On the left you see anomaly detection with an empty bottle. It would say not OK because it learned my bottle has to have a yellow or a red content, but white content or transparent is unknown, so this is not OK. But as you see on the two images on the left, we have the cherry label with the apple juice content. It says OK because the algorithm learned OK, yellow background, this I know, the label seems correct, seems good. And as you see on the right, the Global Context Anomaly Detection in HALCON 2205 can detect this kind of context between what is the label's information and what is the background as the content of the bottle. And how this will now look like in the real application images, this will Peter show you.
Thank you, Mario. Yeah, so we want to have a look at this with real images because these are actually the images that we use in our new standard example to show you the Global Context Anomaly Detection. So we have here bottles with banana juice, which kind of white juice, and we have bottles with cherry juice, which should have red juice in it. And then again, we looked at this. We have our good images like this, and we have structural anomalies and logical anomalies. Structural, the label is ripped, or we have a weird red dot on the glass. And logical would be here. We have banana juice, but with a cherry label. And in addition, we have, this is the next one, sorry. So this, with our existing anomaly detection, this would work, okay. This, the anomaly detection has learned, it would describe as okay. Structural would probably work as well. It would say this is not okay, this is also not okay, but logical, it wouldn't detect because it knows the label, it knows the juice, so that's also okay, which it is not. And then we have kind of combination of a logical and structural anomaly, something which we dubbed equivocal anomaly. So something where we have a structural anomaly, which is kind of like structural, there's not two types of juice in a bottle, but also kind of logical because it shouldn't be the red juice in the bottle. So it's a little bit of a combination. This would also be dubbed as OK by the old anomaly detection. Now let's have a look at this with our current new Global Context Anomaly Detection. The good images will of course be dubbed as OK. Structural works here as well. Not OK, not OK. And now logical works as well. The network would detect, okay, this I don't know, the wrong label with the wrong juice. And equivocal anomalies would work as well. The network would say not okay in this case. And how does the Global Context Anomaly Detection actually do this? It is a combination of two networks. So I put in an image like this into the network, and then you have basically a split path, one global network and one local network. And for the global network, in this kind of image, it would detect, okay, on my right side, I only have citrons. So on the right side, there's an apple, so this is wrong. And the local network would detect, okay, on the left side, I see a structural anomaly like this worm in the apple. And then both outputs are combined, and you see both anomalies are detected by the network. Let's have a look at another example. If you have a ground truth like on the left, so a box with lemons on the right side and apples on the left side, and stickers like this on the right side, and stickers like these blue ones on the left side on the apples, then what happens with the networks? If you have structural anomalies, like for example this worm in the lower right here, lower left, sorry, probably the local network would react to and would define this as an anomaly. If you have logical anomalies, like this lemon on the lower left here, probably the global network would react to this and define this as anomaly. And if you have the equivocal anomalies, like the lemon on the upper right here, which has a wrong label, which is kind of a little bit of structural but also logical, probably both networks would react to this error. Now, what happens if you, for example, in your application, you only expect one type of error, so just structural or just logical errors? Well, you can reduce your model to just one of the subnetworks. So with a simple call of setDL model param, you can reduce your model to, for example, the global network, or you can also reduce the model to just the local network. This, of course, comes with a lower training time and also with a lower inference time. But in total, we recommend to use both networks, because in practice, it is not always as clearly distinguished what is an anomaly, if it is structural or logical. Then we have another very important parameter for our global context anomaly detection, and that is the patch size. Note here, this is P patch size, a little bit different from batch size, which is kind of important, because it is important to check, to select a suitable patch size for your anomalies. So in this case, you would think, okay, I can take this big of a patch for the lower anomaly, but this wouldn't detect the upper anomalies. Or I could take a smaller patch size for the upper anomalies, but this wouldn't detect the lower anomaly. So what you do is you take basically a middle ground of both, where in the patch it is clearly visible that there's a distinction between a patch which has an anomaly on it and a patch which doesn't have an anomaly on it. We tested this a lot on different data sets and have a standard value for patch size, and this is very good for most data sets, but of course it's also possible to change it if your application necessitates it. Now let's have a look at the workflow. The workflow, as you probably know from deep learning, follows the same 4 steps always. And this is very similar to our existing anomaly detection workflow, the preparation, evaluation, and inference. That's why we won't have a detailed look at it. For example, preparation, I mean, you know this, you just have to take good pictures that show the object in its good state very well in all variations. But the training is a little bit different. That's why I want to take a look at this specifically. First, you have to set your model parameters. Then you have to create your training parameters. And then, of course, you have to train your model with these parameters. And then there's an additional step, which is special for global context anomaly detection. That is the normalization of both networks. So if you use both networks, then this is always necessary to be done, because the networks output anomaly scores and they have to be normalized against each other. Now let's have a look at the evaluation. This you may be familiar with if you know our current anomaly detection. You have to compute thresholds to make a suggestion what is the difference between good and not okay. And you can select these thresholds freely if you want, but you can also use the procedure compute DL anomaly thresholds to make a good suggestions according to your data, if you have not okay data. Now let's have a look at the inference. This picture you might be familiar with as well, because it looks very similar to our current anomaly detection. So if you just apply DL model on your trained global context anomaly detection model, you will have a picture like this. You get the input image here on the left, the cherry juice, which is mostly correct, but the label positions are off. This cherry picture should be on the top, and this 100% juice should be on the bottom. And this is correctly detected by our global context anomaly detection. As you can see here, it doesn't like the positioning of the labels and labels this as not okay. And now it's also interesting that you can check out each network's response individually. So you could check out, for example, the local anomaly image, so from the local subnetwork, and there you could see this is a logical anomaly, the position of the labels. The local network would define this as okay. It doesn't detect anything that is a structural anomaly here and is fine with this image. But the global network reacts very strongly here to this incorrect label position and defines this as not okay. And then the combination of both, this image is of course not okay. And if you have a look at something different, for example here, an image where you have a structural anomaly, just a scratch on the juice label, the local anomaly image reacts to this very strongly and defines it as not okay, while the global image would not react to this. In combination, of course, this is also found as an anomaly. And then you have a mixture, basically. So you have a wrong label because it hasn't seen this orange in training. And this is sort of a structural error because it doesn't know the orange, but it's also a logical error because the orange doesn't fit to the juice in it. So this is seen by both networks as not okay. We of course have a standard example to guide you all through the steps of the new global context anomaly detection, and you can check this out for yourself and use this of course as a starting point for your own development. Now let's look at some benchmarks we did on this image size. We show you here two different GPUs, so a lower end GPU 1080 and a higher end GPU 3080, and you can see when you have both models, the inference time of course is longer than if you just use the local model or just the global model, but you can also very much increase the inference speed with AI squared inference engines like TensorRT here. And this is even better done when you reduce the precision to float 16, which is not possible on this GPU. Now let's have a look at Deep OCR training.
Thank you, Peter. Yes, training for Deep OCR. You know Deep OCR, a technology which we introduced with HALCON 2011, which could already solve a lot of our customers' applications, but we figured out some cases, especially if there were quite uncommon printing styles, or we had very bad lighting conditions and contrasts, like for example, as you see, reading text on a tire is one example in which the Deep OCR performance was not at the point where we would like to have it. And that's why we introduced a new training functionality for Deep OCR. So basically now it's possible to use your application images to retrain the Deep OCR model which we deliver with HALCON 22.5 and then get even more better results and to solve even more complex OCR tasks. So as I mentioned, the examples reading text on a tire is one example showing the problematic of a bad lighting or conditions or contrasts. And another example basically is what we will have in our standard examples of HDevelop, a reading of a very uncommon printing style, like this printing style is not really included into our standard Deep OCR model. And using the training for DeepOCR, now it's possible for you to train your application and get good results on such kind of applications. And how this is performed in detail, again, Peter will show you.
Thank you. So the DeepOCR training workflow, we've seen this before, also doesn't deviate from the standard deep learning workflow. You have to prepare your data, take pictures of your data, sort it in a data set, then you have to train the network and you evaluate if you're satisfied with your training, and then you can use it in the inference. So for the preparation step, we have the procedure read DL dataset OCR recognition. And this supports actually two formats to be read. So you can have a bounding box format. So your dataset is already labeled in a bounding box format. So you have an image, and each image has associated one or multiple bounding boxes where the word boxes are. And each bounding box also, of course, has a text label. In addition, you can also have the crop format, where for each image in the dataset is actually just the crop of the word. And that's why each image just has a image file name, image ID, and of course the word that is on it.
Do we have something for this in the deep learning tool also?
Yes, actually, you can, for example, use our new example program, DeepOCR pre-label dataset. So you use the existing DeepOCR model to train this, and then you have a pre-labeled, not to train this, I'm sorry, the existing DeepOCR model to infer this on, for example, this image, and then you have a pre-labeled dataset. And as you can see, of course, this is the standard DeepOCR model. It doesn't perform perfectly, but you already have suggested label positions and suggested labels. And this you can use as a starting point in your own labeling then in the deep learning tool. And the label functionality for the DeepOCR labeling comes to the deep learning tool very, very soon, very close to the release of HALCON 2205.
Perfect.
And another thing with deep learning is always that the training data should be as balanced as possible. So if you have different characters, then they should approximately have the same amount of training data. So for this, you can check out with a new procedure to check out the statistics, how many characters are actually in your training data set. So for example, like this would be in our standard example. It is not completely balanced, but the important characters are there. And it is also very interesting to note that characters with a low number of occurrences might not be learned well. So if you don't have a lot of variation in the characters, then it's possible that in your application, when the variation is larger, that these characters cannot be read. Now let's have a look at the training. So this actually works with our read-DL model and our whole DL model world that you are familiar with from deep learning. So you read in your model, then you have your model handle. Then you use train-DL model with the DeepOCR training, and you have a visualization like this, which you are maybe also familiar from deep learning, where you have the current performance on the images and all the data from the training on the left. And once you're finished with the training, you can use evaluate DL model to check out how your model performs on your validation and test data. And for example, compared how does the usual pre-trained DeepOCR model perform on my data, and how does my fine-tuned DeepOCR recognition model perform on this data. And now there's a switch, because when you want to use it now in the application, you have to switch back to the DeepOCR world. So you create a DeepOCR model, then you have a DeepOCR handle, and then you need to set your recognition model that you just trained. So you only train the recognition model, so you set only the recognition model in your DeepOCR handle. Now you have a DeepOCR handle with a trained recognition, fine-tuned recognition model, and now you can use apply DeepOCR on the specific application for which you trained. Another introduction with this version for DeepOCR is not just for training, but it's always important and has been requested by customers a lot, is the parameter alphabet in setDL model param. So if you want to train with new characters, for example, you can set these characters in the alphabet. So in this case, what's the word I'm looking for? Brackets, thank you. These brackets are not trained in our standard DeepOCR pre-trained model. So you need to set them in the alphabet that the model knows that these are the characters that you're training for. And this is also important if the characters are unknown to our pre-trained model. More training data is generally needed for these characters. Another application for the alphabet parameter would be to be able to reduce the alphabet. So if you only expect in your reading like this, like dates, so just numbers and points basically, you can just select points and numbers in your alphabet, and that's how the network only will read these types of characters. Now let's have a look at a success story, which Mario already hinted at, reading text on tires. This was a customer project for us with over 5,000 images and 128,000 words, and 80% of them were used for training. And this is, as Mario mentioned already, low contrast, occlusions third, bevel, emboss, outlines, so it's very difficult to read this text on these tires. And in a comparison, our pre-trained DeepOCR model only achieved about 60% accuracy, and if you fine-tune the model on the training data, we achieved of about 90% accuracy. So a large bump in accuracy for this. Now, last but not least, this was all about DeepOCR recognition, but our DeepOCR detection model has also been improved. So if you have a look at these detections on the right in 2111, they have been improved with 2205 because the text detection model detects the bounding boxes with a better orientation. It is improved with inverse contrast, and also the bounding boxes are more precise. You can see this exactly here when you zoom in on these transistors, that the bounding boxes have a better orientation and are much more precise around the text boxes.
Thank you, Peter. So much about training for DeepOCR. Don't miss your microphone.
Sorry.
The next topic is the print quality inspection. So just a short recap, what is print quality inspection, or PQI for ECC200? Basically, the print quality inspection is a standard to create the quality of printed ECC200 codes, to make sure that if you print the code and you get a certain grade, that it can be read by any other code reader out there. So here we made some improvements to make it even more robust, so the grid determination is more robust. We improved the usability by adding new procedures, and very important always for you, our customers, is that we made it quite much faster, so it's now 100% faster. And the details about it, again, I will switch to my colleague, which has much more knowledge about it than I have, to Peter.
Thank you very much. So Mario mentioned more robust. So this is the first thing that we want to look at. So the detection of the finder pattern edges is much more robust. So on the left side, when you see 2011 progress, the reader is confused about all these artifacts, basically, are also detected as edges. On the right side, with 2205, only the relevant edges are considered. And this makes, of course, the detection of the finder pattern much more robust. And in the same vein, the module centers in the finder pattern the detection of the module centers is improved, and this, of course, results in a much more robust and accurate PQI module grid, which is also important for the grading. Then there's the improved usability. So we have now a procedure to get your grading results in just one single call, and then have a handle grading results, which you can check out in your handle inspect. So before, this was very cumbersome, where you had to use multiple calls of get data code 2D results with different parameters to get your total grading results. And now there's a procedure, grade data code 2D, which does all of this for you. And with this procedure, you can even put as an input the different kind of standard that you want. So for example, these kinds of standards. Of course, only the standard that is applicable for your data code is going to be available here. In addition, it has a format key where you can put in numeric or alphabetic. So if you want numeric in your codes or alphabetic in your codes, you can also choose this in this procedure. In addition, if you use the mode all existing grading results are returned in one large dictionary. So if you want all of your results into one, then you can just use this mode and you get all your information in one dictionary.
Thank you. So these were the topics around the print quality inspection improvements. Last but not least, we have a selection of, we call it notable quality of life improvements. This basically is a summary of new operators and new functionalities which we included into HALCON 2205, as well as speedups and improvements to existing operators. And just to start with, 2 or 3 of the main topics is that we added new operators to smooth images with arbitrarily shaped regions. We have a new histogram equalization operator. Generic shape matching, which we introduced in latest HALCON releases, is now also available in the code generation of the HDevelop assistant. And of course, speed, and the details. Again, you know, Peter.
Thank you very much. Yeah, Mario mentioned mean image, a mean image with an arbitrary shape. Yeah, this is called mean image shape, and you now can filter with arbitrary regions. So for example, if you put in an oriented rectangle like this and filter this image with this, you of course get blurred regions in this direction. But if you turn the rectangle 90 degrees, you can preserve these edges quite well and get the other edges 90 degrees from this blurred out. And if you just use a circle, you get a mean image that is very balanced. So why is this important? Well, you can think of an image like this, so a dot code print where you have artifacts in the background and noise, and with the usual mean image, you not only filter the noise, but also the dot code gets very blurred out. But if you use now a circle, for example, that is more closely resembled to the shape of the object, then the dot code gets preserved better, while the noise also gets filtered out. And this is can be important in different applications where you want to preserve the object shape that you want to preserve, and filter the noise that is not associated with the object. This can be an arbitrary region, not just rectangles or shapes, just any region that you can define. Then we have the new operator, which does linearization of the local histogram, histo image rect. If you have an input image like these capillaries here, when you use the normal global equihisto image, the equalization is not as good. But if you use the new one that does the linearization locally, the contrast gets much more improved. And this is, for example, important if you want to threshold these capillaries, which didn't work before here with the global equalization, but with the local equalization, this works quite well. And this operator has different parameters. For example, you can set the mask width, so the area in which the local equalization takes place. If you increase this, the difference in the output image is visible. And in addition, it also has a mode parameter where you can choose accurate, where the transformation for each pixel individually is calculated, or you can use fast, which is, of course, as the name suggests, faster, but the transformation is only done for a subset of pixels, and then it is interpolated between these pixels. And if you have a look at a little bit of zoom in, of course, the accurate mode will be better than the fast mode, but also, of course, slower. Then we have improvements for our HDevelop. For example, you can have a new layout available for the operator window, which you can choose here with this push of a button, 1 column or 2 column for your operator window. So the second column will be the control parameters and the iconic parameters, not above each other, but right next to each other. This is a preference thing, but you can choose it now. In addition, the protection level can now be set for entire directories. So before it was necessary to do a command line interface call of protection with a password for each file that you want to have executed, or do this in a batch script that you'd had to write. And now it's much simpler. You can just put in a directory in this, and then the whole directory gets protected. The variable inspect for Visual Studio is now available for Visual Studio 2022, and that's why HALCON also is shipped now with 2 versions of this, for the earlier Visual Studio version, which some of you might still use, of course, and the variable inspect for the newer Visual Studio version. Then we have improvements for bar and data code. So you know this, find barcode makes use of various features. So it can be read by different decode features. So the standard decoding, or then you have merged scan lines, small element robustness, and so on. And sometimes it was necessary with which feature your barcode was actually read. And this was very cumbersome to check out before. You'd have to have multiple calls on different operators with status and result and no success, and it was very difficult to find this information. But now you can have the value decode feature and get which decode feature this particular barcode handle was decoded. So standard, merged scan lines, or small element robustness. We have improved our ECC200 reader, especially for codes with small symbol sizes. So on the left you can see these codes couldn't be read, which are now read with 2205. And especially codes with very few modules, so less than 16 × 16, can now be read much more robustly. The recognition of these small codes has been increased from 36 to 87% with standard recognition, and even up to 96 with enhanced recognition, and 99 with maximum recognition. Now let's have a look at matching and 3D. As Mario mentioned already, the matching examples are now used, the matching language examples are now using generic shape matching. So if you check out the examples in C#, Python, C++, and so on, they now all use the generic shape matching interface. And the matching assistant has also been extended. So if you're using the assistant, you can now use the parameters starting angle and ending angle in the matching assistant. And the matching assistant has also been extended so that when you use the code import into HDevelop, it also now uses the generic shape matching interface. Then HALCON has been extended with a new 3D operator, dual quad transpoint 3D, which transforms 3D points with a rigid 3D transform. And when this 3D transform is specified by a dual quaternion. So like this, you have your dual quaternion, and then you can transform a 3D point to another point. This was always already inside HDevelop for a line. Now you can do it with a point as well. Now let's have a look at the improvements in deep learning. We already had Global Context Anomaly Detection and Deep OCR Training, but in addition to that, deep learning models are now forward compatible to the last steady version. So if you write a DL model with 2205 progress, you get a DL model handle, and then you can write this model handle on your disk. And when you read this model handle with 2011 steady, this will produce a functioning DL model handle that you can train in your steady version. So, of course, this is limited if you use new technology that is only present in 2205. This won't work, but if you use a normal model that also was present in 2011 steady, you can read this now with the lower steady version. This is only forward compatible onto the current steady version. But so I have the question, why do we offer forward compatibility now?
That's a good question, because actually you might know that there's no forward compatibility for other functionalities. The reason here is quite simple, and it's called deep learning tool. Because the deep learning tool uses always the latest HALCON progress, or tries to always use the HALCON latest progress below. And without this forward compatibility, it wouldn't be possible to load models which are trained with the deep learning tool into the latest steady, and that's the reason why here we have this forward compatibility.
Ah, very good. Okay, last but not least, because it's always very important, we have speedups in the new version. So several operators are now much faster. So you can see this here. We compared this runtimes in percent with the 2111, so the old version, and now these operators are all very much faster. Up until it just needs 10% of the runtime for bandpass image, or high pass image is also much, much faster. And there's another set of operators which have also been made faster on Windows 64-bit that you can see here. You can also see this in much more detail in the presentation that we will send to you, of course.
Okay, thank you, Peter. So basically that's all the information we wanted to provide to you today. Now we will share a link to the survey which we will kindly ask you to fill out, as you can give us your feedback to the presented features. And while you have a little bit of time to fill out the survey, we will go through all the questions and then come back in a few moments to do a Q&A session. Okay, so take your time, fill out the survey, and we will come back in a few moments. Thank you.